So these are the typical steps you go through to analyze this kind of data. Now, we have done all these steps on one spectrum, but of course, if you have 1,000 spectra, you want to do it on all the spectra at the same time. So typically what people will do is they will not process the spectra simultaneously, but they will do a serial analysis. So they process the first spectrum, then the second, and the third, and the fourth, and so on. So this is what you would normally do. You would do a serial analysis. And since we have a list with multiple spectra, we will use here lapply. And we will use lapply to do these steps that I explained. So the smoothing of the peaks. This is a step that I didn't talk about, but you typically also remove the baseline signal. And then the peak picking. So this is put in an lapply. And with this function here, system.time, I can measure how long it takes. So there we go. You see that it took 9 seconds to process these 1,000 spectra. This is what happens when you do it serially. 9 seconds is still okay, but that's because we're only processing 1,000 spectra. Well, how would this scale if we were to process millions of spectra? So for millions of spectra, you would use parallelization. So parallelization is not a miracle solution that will speed up all of your slow analysis. So as I said before, it will only work when the tasks that you run in parallel are independent. So they don't rely on each other. So essentially anything that you can do with lapply can be parallelized. So this data set with 1,000 similar-sized spectra can be easily parallelized using the VIB parallel package. So I'm first going to load it. So it comes with documentation, as you can see here. If you want to use it, I would strongly advise you to look at the documentation. And here you see that it has numerous tutorials that you can look at. Some packages for complex data analysis, they will use VIB parallel under the hood. So they use it without you knowing it, basically.